I'm trying to cut the presentation to at least 15 minutes to give you a break, to take some water and take some popcorn. But let me tell you something. If you lay down in your bed watching those presentations, you're going to fall asleep. Although I yell a lot to keep you awake, it is good to sit down in the kitchen on a hard seat and pretend that you are in a classroom with your notebook and try not to be distracted by watching TV or anything else. Focus on your presentation. That way, you will learn a lot from the presentation, and more especially, take note. Now, we were talking about hub and switch. I said the hub and the switch does not have a big difference, but the technology, physically, if you look at the hub and the switch, they look the same. But physically, there is a big difference because they don't have the same function. Before the switch, the hub used to have the function of connecting computers together. But the way hub sends data create a lot of problem because network used to crash all the time because hub use a broadcasting method. So that means if a hub have 12 port and you want to send data to one computer that is connected to the port, every computer connected to a port will receive that data. That creates a problem because network used to crash all the time. This is the time when a gentleman from MIT said, I'm going to develop something that will establish a point-to-point communication. That means even if you have 48 computers connected to a switch, one computer want to send data to one other computer, that data will go straight to the switch, and the switch will connect that data to the computer where the data is supposed to go. Remember, the frame that carries the piece of data, the frame has the address of the sending computer and the address of the receiving computer. So when the switch receives the frame, the only thing the switch has to do is to inspect the frame and connect the destination computer with the sending computer. And only those two computers receive the data. So at this point, there is not a lot of traffic. If another computer wants to send data to another computer, all the switch will do is to connect those two computers together. So how the switch do that? It is because the switch keep what they call a switching table. If you have 48 computers connected to a switch, and the switching table, you will have 48 lines. Each line will be the MAC address of that specific computer. That means every time you take a computer, take a cable, connect that computer to a switch, the switch identify the MAC address and record the MAC address on its switching list. So when a computer wants to send data, the computer will always send the data to the switch because this is the switch that have the capability, the ability to connect the computer together. So now what this switch will do is identify the address of the destination computer on the frame and look at in the switching list to see those two MAC address and connect MAC address to MAC address. This is the way connection is happening in a switch. But when it's come to a router, unfortunately, the router does not have that technology to connect two computers together to establish that point-to-point communication that allow the two computers to communicate with each other without the interference of any other computer on the network. So because the hub does not have that technology, the hub use a broadcasting method, start broadcasting to every computer on the network. So this is the most important part to understand, the most important difference to understand. The hub use a broadcasting method and the switch use a point-to-point communication method. So it is very important to understand that. Now, the hub has a job. Because the hub is good at repeating signal, remember, I said in the beginning of the class, when you are using a twisted pair cable, the distance between a computer and the switch cannot be longer than 100 meters or 328 feet. So what happens if you have a computer that is placed in an area that is far? You put a hub as a repeater that will take that signal and broadcast the signal to a longer distance. The hub has a job because it can take signal and broadcast the signal to a longer distance. So a lot of time you can use a hub as a repeater, but the function of using a hub to connect computers together, this is not a good way. So some technician use the hub to broadcast signal to many segments on a network. But the only thing it does is to take that signal, doesn't amplify the signal, just send the signal for a longer distance. So the hub can be used as a repeater. And as I explained, the weakest part of the hub can cause unnecessary traffic and data collision that you don't want that. Now, we're going to see another component, which is the bridge. Because what the bridge does, the bridge can reduce the collision caused by the hub. But what we do now is just avoiding using hub to avoid this type of unnecessary traffic that will make our network congested. We don't want that. So hubs are used to connect together two or more network segments or any media type. So of any media type, in larger design signal, quality begin to deteriorate as segments exceed the maximum length. As I said, if the maximum length is getting low, you can use the hub as a repeater, and you can connect many segments of the network to the hub. But most of the time you will have to use a bridge, and we will talk about that to reduce or to eliminate the problem of collision, because we don't want any collision in your network. Hubs provide a signal amplification required to allow a segment to be extended to a greater distance. For that reason, it's good to use as a repeater. A hub has 4 to 48 ports, the same as the switch. A hub can have 4 to 48 switches. Remember, I said before the switch exists, the same job the switch is doing now is the same job the hub used to do, with the only difference, the switch uses a communication method where it can establish a point-to-point communication and eliminate all the problem we used to have with hub, which is congested network because of too much traffic. So anything you're going to do now, you're going to use a switch. The switch as I said, connect several computing devices together on a lane. A switch can have up to 48 ports. Switch direct traffic in a LAN using a point-to-point communication. We explained all of that. Switch receive frame from the network interface card of the sending computer via a twisted pair cable. And the switch use the MAC address to connect two computers together. A computer send a frame to the switch, then the switch look at the frame to see where that frame is supposed to go by using the MAC address that is in the frame and connect those two computers together. So the switch is in the middle of most local area network because this is the switch that allow data. Now, there is something that I want to add. If the switch doesn't have more than 48 ports, although there are Cisco switches that have more than that, but any Soho switch that you buy will have 4 to 48 ports. Now, what about if you have more computers? If you have more computers, you can connect many switches together. If you look at on the switch, you will see a port here. We call it a uplink port. So if you have many switches, each switch will have different ports, but they will also have a uplink port. Now, if you want the mistake a lot of technicians make, if you have a lot of ports, like you think you can take that port and connect those two uplink ports together. No, this is not the way you do it. If you take the two uplink ports, you connect it together, that's not going to work. What you have to do is to take the uplink port and connect it to any regular port. You have another switch. Those are RJ45 port. And you want to connect this switch to, you're going to take that switch and connect it to a regular port. So you cannot connect all the uplink port together. And at this point, you will have what they call a switch tree. So when you connect many switches together by using one uplink to a regular port, one uplink to a regular port, you can connect as many switches you need to handle your network that have many computers, and you call this a switch tree. So this is where I'm going to stop with that video. This is the second or third video. This is the second video, I think. So we're going to have another video. All the video together will compose the presentation, and when I upload them, I'm going to upload them all together. So you have to go from number 1 until you get to the last video, and now you know you have the complete presentation.